Now I take some examples. So my example 2 is, I want to solve the differential equation y dash plus 2xy equal to 0 by power series method. We can solve very easily by our method we have discussed, first order linear differential equation by separation of variables. But just I want to show you how we can apply the power series method by solving the problem, just to do that one. So we are getting here these parts of our section. So we are having each part, we are having one example, because the example will take 10 to 15 minutes. I'm going to explain this one. So that's why I'm getting in part, but we give you the idea that you can just get this whole example and the introduction in one place. Number one. Number two, as I was saying, I will put my notes in description, the links for the notes. You can take the links of the notes and the this playlist for this power series method there, so you can get all the examples and also the theory. Number three is that you don't forget to press the bell icon, so you can get the notification and you get the information about the videos we're going to develop for the differential equation. I would like to mention that we have developed also the videos for the linear algebra, for the solving the system of equations, and also for the vector calculus. So also you can find in our channel the 10 channel, the network, educational network. You can get it from there. So we come to this example, the first order linear differential equation. We look on the coefficient. The leading coefficient is a1 of x, and a1 of x is equal to 1. We know that a1 of x is 0 of x. A1, when take x equal to 0, a1 of 0 is equal to 1 is not equal to 0. So we say x equal to 0 is ordinary point. So when it's ordinary point, we can discuss the solution of the series about this ordinary point x equal to 0. So we have this ordinary point. If one can discuss the solution of this one about x equal to 0, that means we can write y equal to sigma n is from 0 to infinity cn x to the power n, and then our y dash, as I mentioned before, we get here sigma n is equal to 1 to infinity n cn x to the power n minus 1. So I substitute these two values in my differential equation. My y dash, I get here sigma n is from 1 to infinity n cn x to the power n minus 1, plus we are having here 2x, and we are having sigma n is from 0 to infinity cn x to the power n equal to 0. From my experience, I just tell you a very important thing, that whenever you are having here the coefficient depending upon x, so the first step, the next step will be that you take this coefficient x inside. That's here. So if you don't take inside, then in the method there will be some error which you are going to occur, and your result will be not that correct. So we take this one inside, and we'll get here the modified form of our differential equation is, we are having here now, we're having here sigma n is from 1 to infinity, this is my y dash, n cn x to the power n minus 1, x to the power n minus 1, plus we're having 2 outside, we're having sigma n is from 0 to infinity cn x to the power n plus 1, because we have taken the x, we multiply here x into x minus 1, here x into x to the power n, they become here x to the power n plus 1. So next step, we are discussing the method. We are just introducing and discussing it. We want to make two things. Number one, we equate the power of the value of x, so we can take it out. Actually, we are going to take the things like this one. We're having some power of x, say it's m, and here we're having some sigma. This is same for both of them. Here is m. For example, I'm taking. There are some terms here, and we are having here these things must be equal. So make the summation equal. We want to make the power equal. That's the main technique which we are going to use in solving this equation. So you must be very careful and see it, how we are going to achieve this one. So this is the main idea. If you look on one example and you understand that one, then that will help you to solve the problems here. So I'm just going to remove this one. The idea you keep in mind. Here we can say summation is not equal. The first one is from 1 to infinity, second one is from 0 to infinity. Here power is x is equal to n minus 1, here is n plus 1. So we put here that my n minus 1 is equal to m. When I take this n minus 1 equal to m, then we can have here the values. I just change the color because it's not the nice one. Look on the video. We take here blue one. N minus 1 is equal to m. So what's my n? My n is equal to m plus 1. And when n is equal to 1, here we're having n equal to 1, put here n equal to 1, that will give me m equal to 0. When n goes to infinity, then m also goes to infinity. Then here is n is infinity. Infinity minus 1 is infinity, so m is also going to infinity. This is number 1. We come to the second term. In second term, we are having here the value. We are getting here the value n plus 1 is equal to m. So it's my n. My n is m minus 1. Now if my n is from 0, when I take here n equal to 0, what do we get? We get here m equal to 1. And we take here n equal to infinity. So here infinity plus infinity is infinity. So we say m goes to infinity, then m also goes to infinity. So we have this information. We use this information to rewrite our equation that's in power series. This is my equation 1. To rewrite my equation 1. So we're using this idea. We change this one to m. We get here x to power m. This is n. What's my n is m plus 1. C m plus 1. And here is n. This is also m plus 1. So just substitute this one, replacing n by m plus 1, and here n plus 1 by m. So guess what's my summation? Now my m is changing. What's when n equal to 1, m equal to 0, and here is from 0 to infinity. This is my first term. I come to my second term. I have 2, then I write my summation. Now summation is n equal to 0, where you get m equal to 1. So this m is from 1, and when n goes to infinity, m goes to infinity. Okay. Then change inside, n is changed by m minus 1. We'll see m minus 1. We get here x to power m equal to 0. So this is the situation I got. So I simplify it further. Now you can see the first step, I make the power equal. Now to make power equal is main thing. To make summation equal is not difficult. For example, I am having here any summation sigma, m is from 0 to infinity. For example, I have x to power m. So if I want to change it to 1, so here is cm. I write like this one. Then I take m equal to 0. This is 0, this is 1. Get here c0. Then my next summation is starting from 1 to infinity. I take one term out. For example, I want to change it from 2 to infinity. Now what I do, I say this is equal to c0. With c1 is c1x. Now what's the next term? Next term will be m is from 2 to infinity, cm, x to power m. So it's not difficult when we want to change the summation. Now here we can see this summation is from 1 to infinity, this summation is from 0 to infinity. So what do we take? We take the term with m equal to 0 out. When I take m equal to 0, I get here c1, and here is c1, and m equal to 0 is 1. So we get here c1 plus sigma. We have m is from now 1 to infinity. Because from here, we have taken already term m equal to 0 out. Now summation will start from 1 to infinity, the same one, m plus 1, c m plus 1, and get here m plus 1. There is no change in this term. We get here 2 sigma, m is from 1 to infinity. We get here c m minus 1, x to power m equal to 0. So this is our next step that we have achieved, that we have made the summations equal and make the power equal. Our next step is not difficult. We are just going to take this summation out and this one out, and we can write our solution. Like this one, we are taking the summation out, and also the power of x out. They are both are equal, so we can take them out common. And when we take them common, we will get here our equation in this following form. We get here this is equal to c1. We get here c1 plus sigma m is from 1 to infinity. What's inside? Inside we get here m plus 1, we have c m plus 1, then here we get plus 2c m minus 1, here is m minus 1, x to power m, we say this equal to 0. So we get here this situation, this my next equation which we get here, we have summation equal power of x equal. Now we say, we compare the right hand side. If I write my right hand side is 0, the sigma m is from 1 to infinity 0 x to power m. We compare the coefficients of x to power 0. The coefficient of x to power 0 is this coefficient is c1 equal to 0. We get the coefficient 0. The x to power m is our m plus 1 c m plus 1 plus 2 c m minus 1 equal to 0. What's my m? My m has value 1, 2, 3 and so on. These are my values because my m is from 1 to infinity for all values of m. We get here this one. Now this we get here, this number 1. This is number 1 we have taken somewhere. We take about this number 2 and this number 3. Now the whole game is between number 1 and number 2. We get the value of c and then we substitute the values of c in this equation, which is our c0 plus c1x plus c2 x square plus c3 x cube and so on. One more thing which I would like to mention, our equation is of first order differential equation. We will get only one arbitrary constant. So this means we can find the value of c1, c2, c3 in terms of c0. So let us see how is the things are going to happen. So here we can have the one value is known to us that c1 is 0.